Hi there, folks. Today we're looking at writing linear equations. And there are three formats that we know of for a linear equation. There's point-slope form, there's slope-intercept form, and there's standard form. Remember, point-slope form is the one that gives us any point on the line in addition to the slope. And it's the idea of that x sub 1, y sub 1 is the point, and m is the slope. Slope-intercept form, of course, gives us the slope and the y-intercept. The y-intercept is given there in the form of b. And then standard form is just kind of a rewriting of one of those other two. All right. And so as we progress through this, there's a couple ways that we can write equations for point slope and slope intercept. Probably the easiest is to always start with point slope. All right. Point slope can always be achieved very easily by finding the slope and the point. Slope intercept, we would need the slope and specifically the y-intercept or the b value. Standard form, there's not really a great way to get A, B, and C without doing some memorization in terms of certain situations. It's easier just to write it in one of the other formats and then convert it to standard form. Okay, and so as we look at writing equations here, we're just going to start always with either point slope or slope intercept, depending on what the problem gives us, and then move it to the format we want from there. Okay, for example, if I look at something like this guy, it says, write the equation of the line in point-slope form that passes through these points. And so when you think about point-slope form, it's named because it has a point and a slope. And so right now I have 2 points off the line, so the point thing is done. All I really need is the slope, all right? And so to find the equation of the line in point-slope form, I just need the slope for this one. So I'm going to do my slope formula, or you can do change y over change in x. So I'll do change y over change in x. Y was a 5, now it's a 9, it's gone up 4, so the change in y is up 4. X was a negative 1, now it's a negative 3. The x value has gone down 2, so it's a negative 2. So my slope is a negative 2, all right? And again, if you do the slope formula, it will yield the same thing. But now point slope form, I just plug it into that form and it's okay. It's y minus y sub 1 equals m times x minus x sub 1. So I plug in the slope, which is negative 2. And then I plug in a point, and it doesn't matter which one I choose here. So maybe I choose the first ordered pair, and I say, okay, that's going to give me a plus 1 here, because remember, there's a minus sign built into the formula, so it's x minus a negative 1, so it's like the opposite, all right? It's an opposite sign in the formula. And then over here, it's a y minus 5. And that's it. There's the equation of the line, okay? It would be just as acceptable to have used the other point, which would look like this. Okay? And just be really careful with your signs here. The most common mistake when we're writing in point-slope form is to make a sign error. And to be perfectly honest with you, this is probably the easiest format of the equation to write lines in. All right? If you are ever asked for the equation of the line and it doesn't specify what format, this is the easiest one. All right. The downside to this is we know that one line can probably have an infinite number of equations that represent it. So here I have 2 equations that are literally the same line. So it's not as universal in terms of recognizing a line. By writing in another format, we get kind of one thing for everybody. So no one has different equations written down. For example, if I look at something like this guy, write the equation of the line in slope-intercept form that's parallel to y equals a negative 2x plus 4 and passes through the point negative 6, 4. Okay? And this time it asked me for slope-intercept form, which means the 2 things that I need the slope and I need the y-intercept. Okay? And probably the easiest way to do this is just to start with the other format. See, I have the slope essentially and I have a point, so it makes more sense to write it in point-slope form, and then we can easily rewrite it. Okay, so for this one, if I were to write in point slope form, because I want to be parallel to that line, so if you look at this guy has a slope of negative 2. I want to be parallel to that line, so I want my line to have a slope of negative 2. Okay, and so if I wrote this thing in point slope form, the slope goes here. I plug in the ordered pairs. That's a plus 6 and a minus 4. There it is in point slope form. And again, that made sense because I have a point and I have the slope. If I want slope-intercept form, it's just a matter of rewriting this thing to get y by itself. So here I would distribute this negative 2. And then to get y by itself, I'm going to add the 4 to each side. So slope-intercept form, I end up with y equals negative 2x minus 8. Okay? That's one option. The other option here is if you are really bent on going right to slope-intercept form, again, the 2 things that we need are the slope and the y-intercept. If I were to kind of take a blank slope-intercept form equation, y equals mx plus b, And instead of thinking as x and y as my variables, think of them as the ordered pair. I can plug an x value in for x and a y value in for y. I could plug the 4 in here. I could plug the -6 in here. I could plug the slope in for m. And now I could use this equation to solve for b. So I simplify, I subtract the 12 from each side. So I get b equals a -8. And then after I have that, okay, I have the slope and the y-intercept. Now I can write it in slope-intercept form. Y equals -2x minus 8. Okay? Either one of those methods is acceptable. I think writing in point slope form is typically easier when you're given a slope and a point. Okay? If I look at something like this guy, it says write the equation of the line in standard form this time that's perpendicular to y equals a -2x plus 5 and passes through the point 3, -1. And so once again, I think it's easiest to start with point slope form because I basically have the slope and I have a point that's given. And so for this one, if I look at this guy, the slope on this line is a -2. So I want the slope of the perpendicular line this time. So the opposite reciprocal, that's a +1/2. Okay? And then if I'm going to point slope form, it's y, x over here. I plug in the slope. I plug in the ordered pair, so -3 and a +1. And now from here, it's really easy to rewrite this in slope-intercept form. And so I kind of pass through all the formats when I do it this way. I'm going to distribute that 1/2. And now I'm going to subtract the 1 from each side. So again, I'm passing through kind of all the formats here. And if you need to take this off to the side and get common denominators and that kind of stuff, that's fine. I think this is one we could probably do in our head, -5/2, because again, a 1 is a 2/2, so -3/2 minus 2/2, -5/2. And so that is slope-intercept form. To get this thing in standard form now, let me write this guy down up here. So again, I'm just showing you all three formats as I work my way through this thing. To get this thing in standard form, I got to get x and y on the same side, so I subtract the 1/2 x from each side. And the order in which we write this is really important for standard form. So it's a -1/2 x plus y equals a -5/2. And remember, with standard form, we have these little stipulations of you can't have a negative to start for the a value. You can't have any fractions. So I'm going to get rid of that fraction by multiplying by 2, and I'm going to make it positive by multiplying by a -2. Okay? So remember, standard form, we have some little nuances that we have to watch out for. So here, that's an x minus 2y equals a +5. And that is standard form. Okay? Once again, the other option here is you could go right to slope-intercept form by kind of doing what we did in the last example and finding the b value, but you're still going to write that y equals 1/2 x minus 5/2, and then convert that to standard form. Okay? But again, remember, standard form, you got to clear those fractions, and you can't have x start with a negative. If we look at these next two, it says write each equation in slope-intercept form. And so, really the only time it's easier to go right to slope-intercept form is if you literally have the slope and the y-intercept. And so if I look at these two examples, if I look at this first one, I should be able to look at this and find the slope based on the picture that I see, based on the graph. And so I see that it goes through this point, this point, this point. And so I mark a couple, and just be really careful. Sometimes it'll come close to a point, like this guy right here comes close to that point, but it doesn't go through that point. So just, make sure you're using points that the thing goes through. And so as I look at this thing, just from the graph, I can come up with the slope, and I can say, hey, this thing is down 2/3, so the slope is -2/3. So I have the slope, and then right here I have the y-intercept. It's this ordered pair, 0, 3. If I have the slope and the y-intercept, I can easily go right to slope-intercept form. It'd be a waste of my time if it asked for slope-intercept to put this thing in point-slope form first. Okay? Now, could I put it in point-slope form, and could I use any of these points? Yes. And as I rewrite it, I'm going to get this same thing of y equals -2/3 x plus 3. Okay? If you have the slope and the y-intercept right out of the gate, you can go right to slope-intercept form if that's the question it's asking for. Okay? If I look at the next one, same kind of thing. I kind of start identifying points that this goes through. It goes through this one. Looks like it goes through this one. It goes through that one. And so I started thinking about, okay, slope-intercept form rather. I can see the slope. It's up 2 over 1, 2, 3, 4, 5. So the slope here is up 2 over 5. So it's 2/5. But then the y-intercept, you might be looking at that going, maybe I'll just take a guess at it, right? It's some kind of fraction right here. And here's the thing, if you're clever and you think about slope in a little bit of a different way, you can come up with the value that's there and figure out that that's a negative 3/5. Okay? And so if you're smart like me, if you've been doing this for a million years like me, you can maybe go, oh, y equals 2/5 x minus 3/5, and say, yeah, that y-intercept for sure is definitely a negative 3/5. Okay? But if you're looking at that going, it's some kind of fraction, but I'm not sure, well, this is where you would want to go to point slope form. Okay, so if I did point slope, let's see, I got the 2/5 here. X, I'm going to plug in one of these ordered pairs, so maybe I identify like this one. This one's at -1, -1. Okay, so maybe that's the ordered pair I plug in. And now I distribute. And then subtract that 1 from each side. And if you need to take that off to the side, you can. But if you do 2/5 minus 1, well, you get a negative 3/5. And so if you're looking at this thinking, I'm a wizard, I am. Okay? But no, if you're looking at this thinking, how in the world did he get that exact fraction? Again, I just think about slope in a little bit of a different way. You know, the slope of 2/5 means, yes, up 2 over 5, but it also means up 2/5 over 1. Isn't that the same thing as 2/5? And so I thought about it this way. I said, oh, that's 2/5 over 1. Okay? And so if I travel up 2/5 and over 1, up 2/5 over 1 puts me at this y-intercept. Well, yeah, I was at -1. I went up 2/5. Now I'm at negative 3/5. Okay, and so thinking about slope in a little bit of a different way, and you know, we've thought about slope in probably in different ways before, like instead of up 2 over 5, yeah, up 4 over 10. Okay, but you could think about it as fractions or decimals, you know, going up 0.4 and over 1. That's the same thing as 2/5. Okay, so think about slope in a little bit of a different way, and you might be able to take a little bit of a shortcut here. Okay, but if you're not sure, hey, plug it in, put it into a point slope form and just rearrange it. Okay, do whatever works best for you, whatever is easiest when you get to this problem. Okay. If I look at this one, it says a line passes through 5,2 and 3,2. Write the equation of the perpendicular line that passes through 4,1. And notice it didn't specify which format of the equation I want this in. So I can put it in any format, but make sure it's simplified all the way. Okay. And so as I look at this thing, the first thing I need is the slope. And so I can do my slope formula or change in y over change in x. I'm going to change in y over change in x. Y was a 2, now it's a 2. Y hasn't changed, that's a 0. X was a 5, now it's a 3. It went down 2, that's a negative 2. So the slope here is 0. And hopefully as I write this down, I recognize that a slope of 0, that is a horizontal line. Okay? And here's the thing, I could go ahead and plug this into point slope form or something like that, but I should recognize right away that a horizontal line is y equals a number. Okay, and as I look at the ordered pairs that were given, y equals what? When I look at the y values, it's 2 every time. You should be able to tell right away that this has an equation of y equals 2. Okay, when I look at the thing that goes through these 2 points. Okay, it's got a slope of 0 and it goes through 2 every time for the y value. It's y equals 2. If you did point slope form here, you should get the same thing. Y minus 2 equals 0 times x minus 5. This is just not acceptable right at the moment because I can simplify 0 times anything as 0. And now we're kind of not in any format at this point. Add the 2 to each side, we get y equals 2. Okay, so that's the equation line that goes through those 2 points. But keep in mind, it didn't ask for that equation. It asked for the equation that's perpendicular to that. And so if we're perpendicular to a horizontal line, and so this takes a little bit of thinking. All right, if we're perpendicular to that horizontal line, we need a vertical line, which is in the format x equals a value. And so the question becomes, x equals what value? Well, I want this vertical line to go through this point. And this point has an x value of 4. So I want this to be the equation x equals 4. Okay? And one of the other ways that might be helpful to think about this, believe it or not, is just to graph the whole thing. If you see this on a graph and you see a horizontal line, you could easily plot 4, 1 and draw the vertical line because you know that's got to be perpendicular. And it's going to be very obvious that it's x equals 4. okay? And so again, a vertical line is x equals a number. Well, if I have a vertical line that goes through this point, and at this point has an x value 4, well, every ordered pair on that line is going to have an x value 4. It's the equation x equals 4. Okay, so watch out for some of those kind of things, you know, those special cases of vertical and horizontal lines. Okay. And then this last one, write the equation of the line in standard form with an x-intercept of 4 and a y-intercept of 6. What students will do here is they'll jump the gun because they know that writing equation in standard form, when we graph it, we use the intercepts. So they try to do stuff like this. All right, this is the most common answer I get. 4x plus 6y equals, and then they just kind of take a guess at this last number, or they do like 4 times 6 and do like a 24. Oh, okay, yeah, you know, that's pretty interesting. And here's the thing, that's not quite right, okay? When you start to look at this thing, if you were to literally find the x-intercept and divide by each side by 4, you get a 6, which is actually the y-intercept. And if you divided each side by 6, you'd get actually the x-intercept. And so really these mixed up. So maybe you could switch those, but either way, it's not in the right format. This is a trap type of questions because the idea is you don't necessarily want to go right to standard form. With all our other equations, when we did standard form, we wrote it in a different format first. We either wrote it in slope-intercept or point-slope form first. We'll do the same thing here. And think of each of these as an ordered pair. This is the ordered pair 4, 0. This is the ordered pair 0, 6. Okay? And I'm not saying you couldn't figure out and go right to standard form, but it's really easy just to look at this and say, okay, let's find the slope. Change in y is a 6. Change in x is a negative 4. So the slope is a negative 3 halves. Okay? And then from here, I could go to point slope form, but this one's really easy to go to slope intercept form because look, right here I have the y-intercept. Okay? Look at what's given and try to take the shortest path possible. So here y equals a negative 3 halves x plus 6. And now I can easily write this thing in standard form. I add the 3 halves x to each side. I get x and y on the same side. And now I want to clear those fractions. I can get rid of that 2 by multiplying each side by 2. And again, so the easiest path typically to standard form is to get the thing in slope-intercept form first and then rewrite it. And then from here, you can easily check this thing. Plug a 0 in for y, you get x equals 4. That's the x-intercept. Plug a 0 in for x, you get y equals 6. That's the y-intercept. Okay? So again, when you're doing these things, look at which format would be easiest to get this thing into, and then rewrite it from there. Okay? Point slope, you need the point and the slope. Slope intercept, you need the slope and the y-intercept. And then standard form is always just a rewrite of one of those two. Okay?